Live IELTS class. My name is Adrian and I'm streaming to you from beautiful Budapest here, the capital city of Hungary. I hope everybody is having a good week, a healthy week. Looking forward to a good weekend. Hi Pachu. Hi Begjan. Hi Arpan. Good job Begjan on all those task 2 writings and editings. Fantastic. You're improving. Hi Renu. Nice to see many of our students. While we wait for some more of your peers, of course, this lesson is presented to you by aehelp.com. The materials we're using for today's reading class strategies to get those extra bands, they're coming from academicenglishhelp.com. And for general IELTS, check us out at gieltshelp.com. That's general IELTShelp.com. On both of these websites, we have loads and loads of materials to help you improve, communicate better, get higher band scores. The websites look like this. This is the academic with the blue background. Click that big red button to get access to over 100 hours of video lessons, a fully interactive course for your phone, tablet, PC, and original practice exams. This is the general version here with the green background, and you can click that big red button to join us there. Hi Preeti, hi Abhishek, nice to see some of our members joining in on time as well. Again, students, if you have questions, just let me know. Send me an email, adrian@aehelp.com. We are British Council test registration partners, so we have lots of insights into the mechanisms of this exam. So today, for this class reading, tomorrow, members, we will do a task 1 writing class, and then that will be followed by a task 2 class for everyone. Today's reading is Explosions in Space, Supernovae. Now, notice that this is reading passage 3. In the IELTS exam, both the academic and the general, passage 3 is the most difficult. In the general, it's section 3, which is the one long passage, kind of similar to these academic passages. It's the most challenging. Usually they're the longest. They have the most difficult questions, vocabulary, and topic. Okay, so in most cases, passage 3 will be the most difficult. Make sure to try and leave 20 minutes for this passage. If you're having a little bit of a tough time understanding, don't panic, don't freak out. Just remember, this is the most challenging type of passage. All right, so reading passage 3, Explosions in Space, Supernovae, and then here we have this beautiful picture of what looks like a bright star or bright explosion. Now, for those of you who are going for those high band scores, band 7, 8s, 9s for your express entry visas or doing your master's, PhD, that requires those higher band scores. Tip number 1, okay, is you must read the whole passage. Okay, so we recommend for everyone who wants to do a good job on the IELTS to read the whole passage and then answer the question. Skimming and scanning is a very weak strategy. It gets you low band scores. And for those of you who are looking for master's, PhD, or express entry visas, you definitely have to be able to read the whole passage. If you're not fast enough, that means you just have to practice more reading to build your comprehension and fluency. Dr. Krishna, nice to see you in the class as well. All right, so tip 1, you must read the whole passage. Okay, here's strategy 1. Read the title. Think about what it means. And think of all the information that you already know about this topic. If there is a picture, like in this one, remember to visualize and see the information. Okay? When there's a picture, it usually means it's a very visual topic. So going back to our reading, explosions in space, supernovae. Maybe this is a new word for you, supernovae, but explosions in space, that you can probably understand. So what do you think it means? What is a supernovae? What is an explosion in space? What's the answer to this what question? Hi, Eugen. I love all those emojis. Wavy, panda, and panther head. So what does it mean? Abhishek says it's a catastrophe in the galaxy. What kind of a catastrophe, Abhishek? What would you say? So if you had, all you had is this information, what is a supernova? Supernovae is plural. Okay. So Pachu says it's maybe a collision between stars. Charlie Sen says it's maybe the birth of a star. Charlie, it's actually the opposite. It's not the birth of a star, it's the death of a star. I wonder if anybody came up with that. Okay, so it's the death of a star. Okay, as Pachu said, two stars colliding or a star imploding. Anybody know this word? Imploding? If exploding is then imploding is okay. So I hope that wasn't too loud on the mic for some of you with headsets. Sorry about that. Exploding is a kaboom outward. Imploding is when something explodes inward. So explodes inward, kind of weird. That's why we say implode. X out, im inside. So implode. Okay. So Charlie says, yup, death of a star with the emoji. Perfect. All right. So now we know that. Why? So always think about the what, why, how, right? Why does a star explode, or why does a star crash, right? So why does a star implode? Why does one star crash into another? Can anybody answer those questions for me? Okay, what's the answer to that? So why? But you says maybe something to do with hydrogen? Maybe. Hemant says it's the creation of a black hole. I don't know, Hemant. That might be a stretch, but perhaps. Preeti says, yep, supernova is a dying star. Bhumi says it's the end of a lifespan. Shiro Dijin says too much energy has been released. Yeah. Okay. It's the end of energy. So why does a star implode? End of energy. Burned too much fuel. It's old. The star has become very old. Okay. And why does another star crash into the other? Well, maybe it's in the way. Hey, get out of my way. Bam, boom. Or that other thing that Newton talked about, right? Gravity. Pulls the two stars together. Our old friend gravity. Not even the mighty stars can explain. Or not even the mighty stars can escape gravity. Okay, gravity pulls the two stars together. Now the how, it's maybe a little too scientific. If you know that the sun or the stars burn energy like hydrogen, nitrogen, that's great. If you don't know that, that's fine too. Okay, you don't need to be a scientist to get a good band score on the IELTS. Although reading some scientific articles, especially for you academic students, that is a good idea. So reading some science magazines, reading some information about astronomy could help you For sure. Okay, now let's go look at the questions. So before we begin reading, and students, this is happening fast, okay? So reading the title, visualizing, thinking what, why, how, reading the questions or scanning the questions. You really only want to take about 3-4 minutes for this part of the strategy, okay? So the questions, some of them are good to read because they will help you understand the passage. It will give you some further information. So here it says, reading passage 1 has 5 paragraphs, A, B, C, D, and E. Which paragraph contains the following information? All of this question's information is somewhere in the passage. So it's a good idea to review these before you read the passage. So let's do that now. Read with me. Now, students, this is a reading class for the IELTS. So read with me and read nice and loud, okay? Read nice and loud so you can hear yourself. All right? Here we go. Number 27, mass energy conversion. 28, the requirements for a type 1a supernova. 29, supernovae as intergalactic measuring sticks. That's kind of a weird one. I don't really understand it, but that's okay. I don't have to understand it yet. Okay. Heavy elements come from supernovae. 31, the fuel used for stars. 32, supernovae are the progenitors of much of existence. All right. Now, some of you are probably thinking, whoa, really? This is an IELTS passage in the academic? I'm supposed to read this in English? If I read this in my own language, maybe I don't understand. Anybody feeling that? Anybody feeling like, even if this topic is in my language, I might have a tough time understanding the passage? Okay. Well, for those of you who are feeling that, remember, passage 3 is looking for band 7, 8, 9 candidates. Also, remember that in college and university, even native English speakers don't understand all of the information they read in their textbooks. They have to use critical thinking, analysis, or analyses, and understanding from context. Okay, so that's what this is looking for, all right? For passage 3, especially in the academic IELTS, they're looking to see how well can you, and it doesn't matter if you're non-native English or native English speaker, how well can you understand challenging academic information that might not be completely clear to start from context. Does that make sense? So the reason I'm telling you that is don't freak out if you read a sentence like supernovae are the progenitors of much of existence. Maybe a native speaker won't understand that either. Okay? But at the end of the 20 minutes after reading, they'll be able to figure that out. Okay? That's the idea for those high band scores, okay? So that's what IELTS is looking for here. All right, let's look at the other questions. 33 to 36. Choose no more than 2 words from the passage. This is sentence completion. And again, all of the information is in the passage. So let's read these. All right. 33, type 2 supernovae originate from a star which is something. The energy producing process in a star converts something into something. 35, the death process starts, all of the hydrogen is used up. The star then begins to process something elements. 36, the first element that can no longer be fused into another element is. Questions 37 to 40. Multiple choice. Now, I know a lot of students hate these multiple choice reading questions. I know I did in university. That's okay. For these questions, don't read the answers. They can confuse you. There's a lot of information there that's wrong. It's maybe not even in the text. Okay? So, just read the statement. The sun will not become a type 1a supernova. Why not? Okay, don't worry about the answers because they will confuse you. Don't even read them. 38, the Chandra-Sekhar limit is. Okay. 39, if two type 1a supernovae are observed and one is brighter than the other, what can be concluded about the dimmer one? All right. And number 40, supernovae can be compared to something. All right, so we looked at those questions. We have a little bit of a more clearer idea of the content, the context. Stay focused, students. I see some of you chatting about where you're at and what's going on. Remember, focus, even if it's tough to understand. Stay focused. So far we spent 3-4 minutes in the real exam to visualize, think critically, look at the questions, try to understand. Now we read. Okay? You have 10 to 12 minutes to read the passage. That is a lot of time. For a college or university native English speaking student, this passage would only take about 4, maximum 5 minutes to read and understand. So 10 to 12 minutes is double. Okay, it's double. All right. Okay, so here we go, students. Let's read together and visualize. Picture what you're reading. Here we go. Supernovae are among the most spectacular events in the universe. They are incredibly powerful. In just a few weeks, they can release the same amount of energy as our sun will release in its entire lifetime. Supernovae are also the origin of many of the elements that make up the universe. Most of the elements of the periodic table require enormous amounts of energy to produce, and supernovae are the only source of this energy. Due to their consistent brightness, supernovae are used to measure large distances across the universe. Now, when I'm reading this, especially actively at home, I ask myself in my head during the official exam, what is this paragraph about? And what's the answer here, students? So what is this paragraph about? We just read this paragraph. What is it about? Now, when you're practicing at home, if you can't answer that question, read the paragraph again. If you can, great. So what is this paragraph about? Give me a nice answer for this. Let's see. And try to make it concise. Okay. So it is about supernovae as the producers of elements and massive amounts of energy in the universe. Hopefully you came up with something about that. So Rajveer, very good. Rajveer says it's the importance of supernovae in the cosmos for elements. The periodic table is just what we humans call them. Elena, very good. It's the importance of supernovae. I like that. I really like those answers. Those of you who came up with importance of supernovae. Yeah, very good. So hopefully you visualize that. Fantastic. All right, so next paragraph, B. And we use them as measuring sticks, right? As measuring distances. B, there are two major types of supernovae, type 1a and type 2. Again, read with me, students. There are a number of differences between the two, but the main difference is the process by which they come into being. Type 2 supernovae originate from a dying star. A star begins to die when it runs out of fuel. Fuel for stars is the element hydrogen. For their entire lives, stars fuse hydrogen into helium, producing energy in the process. This energy comes from the difference in mass between a helium molecule and the four constituent hydrogen atoms. Four hydrogen atoms have a mass of approximately 4.0318 atomic mass units, while a helium atom's mass is approximately 4.0026 atomic mass units. The difference between these two values is the amount of mass which is converted into pure energy. In a dying star, there is no more hydrogen. All that is left is helium. At that point, the star begins to fuse helium molecules together to form carbon molecules. Once all the carbon is gone, the star moves on to even heavier elements. And the star consumes these heavier elements at faster and faster rates. A star may take 10 million years to consume its hydrogen, then take 1 million years to consume its helium, 1,000 years for the carbon, 3 years to consume the neon, 3 months for the oxygen, and only 5 days to convert all of the silicon into iron. There is a stopping point, however. Once the core of the star is entirely iron, there can be no more fusion. This is because the small difference in mass that is converted into energy is not present in the case of iron. The star is then left with an inactive iron core. Once the iron core reaches a certain mass called the Chandrasekhar limit, the star can no longer exist under its own weight, and it collapses in on itself. The result is a cataclysmic type 2 supernova. All right, so again, what is paragraph B about? So what is paragraph B about? Give me a nice, clear answer for this one. Now, the reason you're always thinking, what is the paragraph about? Giving a clear, complete answer is because that will help you answer a lot of questions. Okay? So Elena says the formation of type 2 supernova. Yeah, Elena, you're right. It's maybe not the, formation is okay. The process by which type 2 supernova occur, okay? So the process of converting molecules and energy so that a type 2 supernova comes into being. Yeah, and anybody who said something like that, good job. Give yourself a pat on the back. All right. Preeti says it's two main types of supernova and the differences. I don't think the differences have been discussed yet, Preeti. Okay. It's, Herman says it's the types of supernovae, the difference, how it's calculated and formed, the dying star. Yeah. Hemant, try to be concise, so don't use too many words. Again, the process of converting molecules and energy. So students, the reason why you want to do this is because you're practicing active reading. So to get those extra band scores, and that's the topic of today's lesson, you really have to use active reading. Okay, so use active reading. And the first step to this is to ask and answer what the paragraph is about. Now, when you do that, make sure your answer is concise, but also complete, okay? Concise meaning brief, okay? You don't want to keep writing and writing. You don't want to rewrite the paragraph. Your answer should be a fifth of the paragraph, okay? So if the paragraph is 10 lines, your answer should be 2 lines, all right? At most, okay? All right, so let's keep going. We'll do the remaining paragraphs verbally. So here we go, students. Let's read C together. The other type of supernova is the type 1a. Type 1a supernova are formed most commonly in binary star systems, where there are 2 stars which rotate around a common point. For a supernova type 1a to occur, one of the stars has to be a white dwarf. A white dwarf is the remnant of a low-mass star that has come to the end of its stellar life. Our sun will one day be a white dwarf because it lacks the mass needed to blow up in a supernova type 2 explosion. Now, hopefully, some of you remember that there was a question, I don't know if it was a multiple choice or a different one, it was asking about why our sun will not become a supernova. And so here it says lack the mass. Now, I'm not going to jump and answer that question real quick, but I'll just keep in mind that our sun is in paragraph C, and I'm going to keep going. Why don't I jump to answer questions? So why don't I just stop right now, look for that question about the sun, answer it, come back, and continue reading? Why don't I want to do that? What's the logic that I'm using? Okay, so here's my question. Why is it not a good idea to jump back and forth between the passage and questions when I think I see an answer? Okay. So Boomy says it could be a trap. You can lose focus. It's interrupting. Yeah, those are some really nice answers, Boomy. And I can't read the Cyrillic, but it's very good. Preeti says lose concentration. Yeah, absolutely. So the reasons you don't want to do that, there are actually several. You can lose your focus. There can be a better answer later on. Okay, remember that, students. The IELTS is like a college or university exam, meaning you have to give the best possible answer. So you might find one answer, but maybe there's another answer that's even better in the next paragraph. And now you're going, oh, wait a second, what's going on? No, wait, I think this is the, okay, then I have to, okay, so I'm going to stop again, and I'm going to go to the questions, and I'm going to use this one, and I'm going to forget the first one. All right, cool, now I did that. I think I got it. Where was I? What was I reading again? All right, so that's what you want to avoid. All right, so you can lose your focus. There can be a better answer later on. And some questions, especially for high bands, high band questions require you to have an overall understanding of the information. So again, for those of you who are going for those high band scores, if you lose the bigger picture or the inferred information, then that can cost you marks, okay? Plus, it can waste time. Yeah, Adrian, that's right, it can waste time as well. So don't jump, okay? Just keep going. All right. Now, I know I'm interrupting you here again and again to explain, so this is what won't happen in the real exam, okay? All right. So let's jump back here. Our sun will one day be a white dwarf because it lacks the mass needed to blow up in a supernova type 2 explosion. In a binary system, the white dwarf star gravitationally attracts matter from its companion star, with the matter taken from the companion star becoming part of the white dwarf. Eventually, the white dwarf will have added so much mass that it begins to approach the Chandrasekhar limit. Once it hits this limit, just like in type 2 explosions, the white dwarf can no longer sustain itself and the core of the sun collapses. The star blows itself up in an even more spectacular event than type 2 explosion. Cool. So I read this. I asked myself, what is this paragraph about? I answer this question. It's about type 1a supernova and how they happen. Now, of course, I visualize this. So here, I see a white dwarf. Okay, the white dwarf is really heavy. All right, he's super, super heavy. And there's another star here. And this white dwarf is sucking away matter from this other star until it becomes dense enough that it can explode, kaboom, into a type 2 supernovae, and perhaps taking this other star with it, and it's an even bigger explosion. And I even make a note in my head that it's so interesting that type 1a requires 2 stars, as where type 2 requires only 1 star. That's kind of weird. Why didn't they call it the other way? So if you need just 1 star, why not call that one type 1a? I don't know. I'm not an astronomer. Maybe one day I'll find out. But that makes me interested, and it keeps me focused and clear. So a type 1a takes 2 stars. A type 2 takes 1 star. Interesting. All right. So catch the information, find it exciting, find it interesting, even if you're not an astronomer. All right. Let's go on to paragraph D. Let's keep reading. This is reading, so practice your reading. Okay, here we go. Type 1a supernovae are extremely bright. If the sun were to be replaced by a type 1a supernova, it would appear 5 billion times brighter. This brightness is also very consistent from one supernova type 1a to another supernova type 1a. This consistency has led astronomers to use supernova type 1a as what are called standard candles. A standard candle is used to determine how far away an object is. For example, if we observe a supernova type 1a in a nearby galaxy, we can tell very accurately how far away it is by comparing the apparent brightness of the supernova observed with its absolute brightness. Respectively, if the supernova is very bright, the galaxy is quite close. If the supernova is very dim, the galaxy is very far away. So, okay, what is this paragraph about? It's about type 1a supernova brightness for measuring distance. Here I'm kind of picturing it like car headlights. If the car headlights are very, very bright, it means the car is very close. Don't cross the road. If the car headlights are very, very dim, it means the car is very far away. You can probably cross the road, maybe even have a little picnic in the middle of the road. No, don't do that. I'm just kidding. But that's what I keep in my mind, because type 1a supernovae are consistent like the headlights of a car. Okay? All right. Let's keep going. Here we go. Last paragraph, read with me. Supernovae are responsible for every element in the universe that is heavier than iron. Every atom of gold, silver, tin, and lead, as well as 80 other elements in the universe, was born in a supernova. Supernovae are also the origin of most newly born stars in the universe. Our sun, for example, was born from a cloud of dust and gas that was left over from a supernova. The Earth, likewise, was born from a supernova. It is not too imaginative, therefore, to regard the plants, animals, and humans on this planet as a development of this supernova. Every atom of our bodies was once scattered in a supernova explosion. Therefore, many scientists believe supernovae are the crucibles of existence itself. Okay, so what is this about? Well, this is about the importance of supernovae as the origin of elements heavier than iron and about the origin of much of existence and life on Earth. Yeah, so Preeti says it's the importance of supernovae. Good. So hopefully everybody kept a record of paragraph A, B, C, D, E in their mind, and now we can answer the questions. And hopefully we can answer some of these without searching. All right. Here we go. Number 27. We have to explain which paragraph contains this information. So matching information to paragraph, this is where that what question will become super useful. Okay, number 27, mass energy conversion. Okay, what does that mean? So it's like changing hydrogen into helium, helium into neon, neon into silicon, something like that. I remember thinking about this. Which paragraph contained that information? 27. So changing mass energy one into the next. We visualize this really well. Okay, Abhishek, be confident and always be confident with your first feeling or your first answer. Okay, Charlie says that's B, and a lot of you are saying B, and I agree that that is B. Okay, so paragraph B. Now, if I'm not 100% sure, if I'm like, I know it's a body paragraph, but I can't remember if it's B or C, then I can go back and check. But I think most of you remember that it's B. Okay? All right. Now, the requirements for a type 1a supernova, number 28. The requirements for a type 1a supernova. Which paragraph was that? What's needed for a type 1a? Okay, now I'm going to show you something kind of interesting here as well. So when I was doing this, I kept a very basic log of information in my head, and I kept it like this. Okay, so here are the paragraphs, and I highly recommend this strategy at home. So A, intro to supernova. B, type 2 supernova. C, type 1a supernova. D, measuring with type 1a supernova. E, the importance of supernova for elements and existence. Okay, so this is my really basic log of the information. So when you're practicing for the IELTS exam at home, definitely for the reading, practice the strategy of creating logs. Okay, you'll have to do that in your mind in the real IELTS, but that will really help you to save time, to be fast when you're thinking about answers or looking for answers, and to be accurate. Okay, so A, intro to supernova. B, type 2 supernova. C, type 1a supernova. D, measuring type 1a supernova. Okay, E, the importance of supernova. So the answer for this question, the requirements for a type 1a supernova, must be C, as Kavya Reddy says. Kavya says, that's C, because I kept a log, right, Kavya? That's what you're thinking. I kept a log, so I remember that. Okay. All right. Supernovae as an intergalactic measuring stick, or as intergalactic measuring sticks. Which one is that? Elena, good job on the previous. Okay. All right. So which paragraph talked about it as Ali? It's not that hard to remember. Once you practice it a couple times, it will really, really happen quickly. Okay. Rajvir, Kamal, they all say that's D. Okay, so B, C, D, so far, so good. Okay, so supernovae as an intergalactic measuring stick, that's coming out of D. Okay, number 30, heavy elements come from supernova. Okay, heavy elements come from supernova. Which one was that? Okay, number 30. Chairish says E. What are the heavy elements? That's what I would ask myself here. What are the heavy elements? And then hopefully you remember gold and silver. Very good. So that was E, and a lot of you got that. Fantastic. The fuel used for stars. What is the fuel used for stars? What is the fuel used for stars? If you can answer that, you can probably answer which paragraph it came from as well. Chai Rish, I see that you answered this one, gold and silver. Very good. Okay. All right, Abhishek says that's going to be B for the next one. Elena agrees. And Hemant says it's hydrogen and helium. Yeah, so the fuel used for stars is hydrogen and helium. And which paragraph talks about hydrogen and helium? Vincent Paul Centino says that's B. Guys, remember when it was talking about converting hydrogen and helium into energy, it's the fuel for stars. Very good. So notice that I don't have to go back and search for all of these answers. And even if I did, I have a pretty good idea of where to go and look and make sure. Okay? All right. And 32, supernovae are the progenitors of much of existence. Now, this statement was really confusing in the beginning when I was just reviewing my questions, but now I have a pretty good idea of where this comes from. So 32, supernovae are the progenitors of much of existence. Luca Sheraifin says E. And Marie Alba agrees, because we talked about that when we summed it up, right? So correct answers are B, C, D, E, B, E. Notice no A, and B is used twice, and E is used twice. That can happen for these questions. NB, you may use any letter more than once, okay? So that can happen. Very good. All right. Okay, students, fantastic. So far, you're doing really well. And notice how that active reading can help save time and save me from going crazy searching the passage all over the place. All right, here we go. No more than 2 words from the passage for each answer. Write it in boxes 32 to 36. Number 33. Type 2 supernovae originate from a star which is, what do you think is the answer? I don't think you have to search. I think you can figure that out. So type 2 supernovae originate from a star which is, Amandeep says dying star. Yeah, you don't have to say star, Amandeep. You just say dying because it's star. A star is already there, so you don't have to repeat the noun. Okay, just the verb. Elena, dying. Yeah. From a star which is dying. Good. You don't have to put the period, students. Okay, all right. 34, the energy producing process in a star converts something into something. Well, for those of you who got this question correct, will most likely get this question correct also. And that's why it's important to get correct answers, because they will help each other. Okay? Abhishek says hydrogen into helium. Yeah. Watch your spelling, some students. So hydrogen into helium. Okay? Those are all going into that 34. It's 2 words. So hydrogen, comma, helium in your answer sheet. Okay? Very nice. Schuber, make sure you don't use the word into. Okay? So don't put this word in your answer sheet because it's 2 words. If you write hydrogen into helium, they will probably mark you wrong. So hydrogen, comma, helium. Okay? All right. 35. The death process starts when all of the hydrogen is used up. The star then begins to process something elements. So when all of the hydrogen is used up, the star begins to process what kinds of elements? Again, I don't think you need to reread or look for that if you paid careful attention. Flower Sun says process heavy elements. Yeah, I would use a relative here, Flower Sun, but you're absolutely right. Heavier. I think they'll give it to you for heavy, but I would say heavier. Because neon and oxygen, they're not really heavy elements. They're just heavier elements. Heavy elements are metals like gold and silver. Okay, so heavier is the better answer there. Okay, heavier. And watch your spelling. Heavier. Okay, yeah, there's an A there. So heavier. Okay, heavier elements. Very good. All right. So dying, hydrogen, helium, heavier. Let's look at the last 2 for this set. Doing a great job so far. Notice that you really don't have to jump around with the passage. Okay, the first element that can no longer be fused into another element is, and again, if you're visualizing, it should be good here. So the first element that can no longer be fused, and I remembered this one because it's the first one that's really a metal, and I'm like, okay, wow, there's all these gases, and eventually it's this solid chunk of, what is it? What is the last element that's like, okay, the star is done, it's ready to explode and be reborn? It's iron, that's right. Okay, iron. Very nice. Good job, Saul, Nelyar, and Natalie Nikiforova. Very nice. And all of you coming up with iron now. That's great. All right. So a little bit of IELTS, a little bit of science. Here we go, 37 to 40, multiple choice. Let's do this. 37, 38, 39, 44 questions left, multiple choice. You want to be able to answer the question and then choose the matching answer. That's the trick. Don't wait for the answers, or don't try to have the answers pop out at your face and go, hey, that's the right answer. It's going to smack me. Right answer. No, you have to look at the question, think about the answer, then look at the choices and figure out which one is the closest match, okay? So unfortunately, students, the right answer is not going to slap you in the head and tell you that it's there, all right? So it doesn't really, sometimes, rare case, if you're lucky, but usually not. Okay. All right. So 37. The sun will not become a type 1a supernova. Why not? Okay. So why will the sun not become a type 1a supernova? There's a very clear answer for that. There's actually 2 reasons that I can think of. Okay. Why will it not become? Why will our sun not become a type 1a supernova? What's the reason? Give me your answer. Yeah, Shirojidin says it's alone. It doesn't have a buddy. A type 1a supernova needs 2 stars. Remember, it's lacking mass, Pachu. That's right. It's alone and it's lacking mass, right? So the sun is lonely and it's lacking mass. So anything here that matches, it is not a white dwarf, It will never reach the Chandrasekhar limit. It does not have a companion star. It is going to be a type 2 supernova. Which one do you think is the most accurate answer? So A, B, C, D. It will never reach the Chandrasekhar limit. It does not. Which one? C, very good. It doesn't have a buddy, right? So, hey, but it's got 8 billion of us, and many times in history we worship the sun, so it's okay. Maybe that's why we were created, because the sun got so lonely, had no buddy star. It said, hey, let me make a whole bunch of little miniature human ants to look at from far away. Who knows? All right, just kidding, guys, but C is the right answer. So the Chandrasekhar limit, what is that? So good job. Everybody figured out that was C. Chandrasekhar limit, 38. What is it? The Chandrasekhar limit. What is that? It's a good one to know. You can impress your friends in a conversation when you bust out this fact. And by the way, this mathematical number or mass or formula was originally discovered by a person in India, a very famous person. That's why it's called the Chandrasekhar limit. Hemant Sharma says the limit beyond which it cannot be decompressed. Yeah, okay, Hemant. All right, yeah. Something like that. So it's the point at which the star can no longer hold its own weight. Okay? So the mass at which a star will blow up in a supernova, the distance between two stars, the time between fusing helium, the distance between... the correct answer is... Drumroll. Yug Patel, I think, took the definition out of Google and pasted it into the chat for us. Thank you for sharing that, Yug. Yug says it's the maximum mass of a stable white dwarf star. The currently accepted value of this limit is about 1.4 m, 2.765 times 1,030 kilograms. Yeah, but for our purposes, A is the correct answer. Okay, good. Number 39, if two type 1a supernovae are observed and one is brighter than the other, what can be concluded about the dimmer one? Read the question carefully and you will figure out that the dimmer one must be further away, just like those car headlights. It is further away. Okay, so B for that one. Last one, 40 supernovae can be compared to. Tricky question. The universe's factory, the universe's graveyard, universe's hospital, the universe's recycling center. Well, I would definitely say that the last one is D, recycling center, right? Explode, becomes a dust cloud, then many years later it becomes a star again. So the last one is D. I can see many of you answering B for this one. That's great, and hopefully you got D for that last one. Sorry for rushing these last couple questions. I was just running a little bit short on time. But regardless, I'm sure that you understood a lot of what's going on now that we went over the passage carefully. Remember these strategies from today. Ask what, why, how for the topic and the picture that you see. Ask what is the paragraph about to enhance your active reading. For multiple choice, think about the answers and then match the correct one. Don't search for every answer, and don't stop in the passage when you think you see an answer. These are the key tips from today's class to get lots more great strategies and HD videos with no advertising in a structured way. Spend a few dollars. Visit aehelp.com for academic IELTS and gieltshelp.com for general. You're very welcome. I see all those thank yous coming up. I appreciate that. This is the general website here with a green background. Click that big red button. And this is the academic with the blue background. Click that big red button to join there. You're very welcome, everyone. Tomorrow I will be back with task 1 for members and task 2 for all chat. So hopefully I will see you tomorrow at the same time for these classes, earlier for members a little bit. Bye for now. Keep it up, guys, girls. Much love to all of you from Budapest. Bye for now.